You can make ROS2 topic echo / map. Okay, and you will find the map here. Okay, now if I want to see the map, let me try to redirect it. To map.txt. Let's look inside. Okay, so these are the parameters of the map. Look, this is the resolution, this is the width, and this is the height, and this is the origin, from where it takes these values. From where it took these values? From the YAML file. Look, let's open the YAML file again. Okay, look at these values, -125 and -237. So these are exactly the same value as the offset position in the origin. Okay, now from where it took this value, the width and the height in pixels, from the PGM itself. Now let me open the PGM. We didn't check the content of the PGM. Okay, and look at the values here. It's something between 0 and 1 or 0 and 255. نعرف أنه الكولر is encoded on 8 bits, and 8 bits it means from 0 to 255. Okay, look, although everything looks white, but some of them are not 255, maybe they are 205. Okay, some of the obstacles you will find them 0, some of the obstacles you will find them smaller than 0. Okay, so there are different values. This is why we need the threshold, and the threshold will give you some flexibility, but later on these values are going to be sailed either to 255 or to 0 for the navigation. Okay, let's see if we have some obstacles over here. Yeah, because mostly it's a free space. Okay, so this is actually the map topic, and this is what you are actually seeing over here. Okay, like 255 to 0. These values are zeros here. Okay, and it will show it like column or by rows. Okay, this is the global planner. So what do you observe when we have global planner? Look at these obstacles, but these obstacles for the navigation are not going to look as thin as this, but we will have some kind of inflation. Okay, and this inflation, it's a parameter that you can play with. It's called an inflation factor. Okay, we inflate the obstacles. Why do you think we inflate the obstacles? Yes, so we will have a margin of safety. Okay, because the robot is not a point, it has also a footprint, and the obstacles also, there are some uncertainty in the navigation. So to make sure that the robot doesn't hit the obstacles, we will tell the global planner, when you plan a path, don't go to the extremes, but just put some margin away from the walls. I don't want you to be very close to the walls. But of course here, sometimes it may have issues. Look, for example, if I consider all this short position as obstacle, maybe it will not be able to plan its path from here. So the navigation, the inflation ratio, it's a parameter that is environment dependent. It depends on how narrow the passages are and what are the available space. If you have very short space, you can make too much inflation, unless you will ban the robot to move from that space. واضح? Okay, so yeah, this is the and this is a parameter we will look at later on in the navigation stack. So all the obstacles are inflated. There are different types. The global cost map. This is the global cost map. So we call it a cost map because when you plan a path, you try to plan it with the minimum cost. So this will add additional cost. You know, this inflation will be like additional cost to avoid the robot from going through some particular points. And the path, of course, when we plan a path, we will see the path, voxel grid, and so on. This is the global planner. Now, this is the controller, or what is called previously the local planner. In ROS1, it was called the local planner, but now we call it the global planner. And this one is going to plan the path within the vicinity of the robot. Now, if I give a path to go from this position to this position, maybe in the middle, the robot will observe obstacles. So this square here, it's the area where the robot is going to take decision on how to avoid dynamic obstacles that may come in front of it while navigating. Okay, and this is going to be handled by the controller or the local planner, and of course it also has some kind of inflation related to it, okay, to also avoid going very close to dynamic obstacles. So the global cost map, this one, will be considered by the global planner to create a path, a static path, and the local cost map will be considered by the robot while navigating. And these cost maps are available here. If I go to Turtlebot 3 navigation 2 package, okay, if I go to parameters, yeah, now it has changed. Everything is within a YAML file. Look, these are the parameters. Where is the global? Okay, global cost. So these are the parameters of the global cost map. There are many, okay, but for us we have been focusing on the inflation. Okay, let me see where is the inflation. Inflation radius, look, it will add 55% of the width, okay, as an inflation radius. So same thing, we have also a controller. The controller server. It has so many parameters. We will explain this. Okay, this is the plugin for the controller itself, and also has an inflation radius in the same way. Okay, so all these parameters can be configured, and usually we configure them to optimize the navigation performance. Of course, these were now pre-configured in order to have the best navigation performance for this very simple use case. So we have the global planner, we have the controller, and we have the map. Okay, where is the controller? Let's see, also we have a MCL particle swarm.
Can you go back to the local one and turn off the map?
Which one?
Yes, this square and turn off the map. Controller. Yes. So why the rider is detecting an obstacle even if the map is not there?
Yeah, the map is a topic. These obstacles are from the physical obstacles detected. It's from here. Okay, this map is just a visualization, okay, but this is the real setup. It's translating the real setup. Okay, so this is, it depends on what you want to visualize. In principle, you should have particles. Maybe it was smooth, so it now knows its position very well. Okay, now if I want to navigate, we can select a point, and look now. Okay, the robot didn't go through here because there is an inflation. It went through a different path. Now it went back because it was cleared. So you see, it took a path and then it changed the path because the controller has detected that there is a free space and it has made the navigation properly. Okay, let me remove the cost map, remove this and only keep the path. Let me increase the path. The alpha head diameter. I can increase this a little bit. 5. Okay, let's try to create another navigation goal. There is no robot model. Okay, look. So the robot is navigating here, and you can visualize. You can see this is the planet path, which is in red, and the followed path, which is the blue. Okay, so we have two paths. Decrease what? I didn't understand what you mean. This is completely autonomous.
Yes, can I decrease it or decrease it when I want?
Yes, from the parameters. Yes, yeah, from the parameters. Okay, now I added the robot model. You can see the robot model here. Okay, so we can play with this. Unfortunately, my computer becomes very slow with gazebo. Okay, look now. This is the planned path, and this is the executed path. Okay, this is how the controller is executing the path. Voila. Okay. So there is also a possibility to publish a point if we want to know a particular location. Okay, so I'm going to use RViz to know the location of this point. Okay, if I click here, in principle, yeah, look, the point will be published here. Look, just a moment. If you look at the bottom. Do you see the bottom? No, it's not. There is something hidden. Okay, let me try to change the configuration. No. Look, if you want to know a particular location, you can use this publish point and put the cursor on any place. You will find the XY coordinate here. So usually this is needed when we want to navigate using Python into a particular point. Okay, imagine that I want to say, okay, this is point 1, this is point 2, and then I want just to specify, go to point 1. So I need to know the coordinates. I need to make a mapping between the semantic name of the location and its XY coordinate. Okay, let me make a very simple programming example on how we can develop a simple navigation script for this. Okay, just not to have I'm going to make a very simple script. I will make a file tb3 navigation.py, and I will add this into the setup.py. Okay. Is it correct? Yes. Now I'm going to bring some code I did before. I want the, it's not here, yeah. Yeah, this one. But I will make a simplified version of this. Okay. Let me create another node. tb3 nav complete dot py. I'm going to divide these two. Okay. This is an empty location. You have the main function. Do I need, yeah, I need this. Okay, let's build it step by step. Okay, so in the beginning, I'm going to make a class navigation node. Let's make it step by step. This is for class. And I'm going to make def init with the subscriber. So as we are going to define a navigation, we need to define a subscriber because it's not for I don't need a subscriber for this, but later on for the velocity. So I need to define RCL pi and to define also node. So because this class is going to inherit from node, and this is just to initialize the navigation node, and I will create the main function, which is going to initialize the node. So for the moment, I'm going to just disable all these kind of things and create a node, spin forever, and destroy. That's it. Let me compile. CL. Just to make sure I don't have any issue with the new code. Okay, I will make some, no complication. I will select a point where I want the robot to navigate. Okay, so inside init, I'm going to create a method that is called send navigation goal. And the send navigation goal here, or move to goal, will have a location x of type int or of type float, and the location y. Location y. So these are the target xy coordinates, right? Float. And let's say theta, which is the yaw. Okay, let me call it the yaw float. This is where I want the robot to go. Let me call it go to goal. If I call this function, I will let the robot go to a particular location. And finally, let me return 0. So, okay, now how can we send a goal location? So in order to send a goal location, we need to call a particular function, which is the action client. If you remember from the ROS computation graph, we have nodes, topics, services, and actions. What's the difference between action and services, for example? Do you remember?
Action or send and okay, action send read and send nodes, but services is only action sending and receiving by publisher and receiver, and the services is just sending.
No. So both are client-service architecture, but the service is blocking. When the client sends a request, the server it will be blocked until it receives a response. But the action, the client can send the request and it will not be blocked. Okay, and usually we use the action when the service may take a long time. So in order not to block the client for a long time, we will allow it to make any action while the service is being executed or while the action is being executed. So why the navigation is developed as an action and not developed as a service?
So it doesn't block.
Yeah, because usually the navigation, it may take a couple of seconds, okay? And this is a long period of time until the robot moves from one location to another. So we don't want to block the whole process. So while the robot is executing, we can receive feedback and we know what is the current state of the robot and so on. So this is the idea. So for this reason, we're going to use action client in order to define an action client for the navigation. Okay. So this will be defined here in the init function. And it will call the action navigate to pause. Okay, so it will create an action navigate to pause, and this one, it's a function or it's an action that is available in the nav to navigation stack. واضح? Okay, so now we are building this step by step. So this is a navigation action client. Okay, let me call it nav action client. So it's an action client. كان من قبل نسميها move base هذه, but now it has changed the name. If you use ROS1, this will be called an action regarding move base. But now move base is no longer part of the navigations to nav2 navigation stack of the ROS2. Okay, that's fine. Okay, now we need to develop this function. Okay, so what we are going to send usually, when we send a navigation goal, we need to define a goal message. Okay, a goal message of type navigation goal to pose goal. Okay, we can see this message here. This is the constructor. If you go to the documentation, or probably here. Okay, so it is a message that will have a certain structure. I want goal, pose stamp. Okay. So actually the type will be of type pose stamp, but we're going to need to put all this information here into this type of message of type pose stamp. So goal message will have pose.header.stamp and the position of that. This is the same as the pose stamp message that we have used before. This is the name of the message, .pose.header.stamp, and you will put the current time. Then pose.header.frame ID. Okay, now this is very important. Why we put map here?
Why we
put map? Why we are putting map here?
Because we needed to read the map nodes from the RViz.
No, because we are going to express the x coordinate, the y coordinate with respect to the map frame. It means global coordinates. Imagine here I will put base link. You didn't know the last lecture, which was important. So base link, this will be a position with respect to the robot frame. If I put, for example, 1, 0, with this frame, it will be 1 meter away from the robot. If I put the map frame, it will be the coordinate 1, 0 in the map. Okay? So specifying the right frame will make a lot of difference, and we will see the impact. When I will run this code, we will see the impact if you change the frame. Now, what we will put here, so of course, at the end I'm going to use semantic name locations, but now I'm going to use so I will put here x, which comes from here from the argument. Okay, let me call x target or x goal. Okay, so this is the goal location where I want to go, and this will be y goal, the goal location, and this is the yo at the goal location. You can also specify in which rotation you want the robot to be. Is this correct now, or there is something wrong? Is there anything wrong here? Okay, we need to convert the yo into quaternion values. Okay, last time we have introduced how to make the conversion. I think it's the TF demo. Okay, quaternion from Euler. Okay, so I'm going to take this one and I will come here. So I will not assign this to Z or anything else. So all orientation will be equal to this quaternion. I don't know whether this assignment will be possible, otherwise we need to make quaternion.x. This is safer, by the way. Orientation.x will be equal to quaternion.x. and I need also to import the library because this is using TF, and we import the TF transformation library, which is the library from TF2. Okay, now let me continue to construct the whole quaternion. I have here Y, I have here X, Y, Z, and finally W. Same thing, I need to change this to Y, this to Z, and this one to W. And of course here I have something wrong because I need to change U by U goal. What will be the value of the roll and the pitch? The value of the roll and the pitch. Zeros. 0 here. Because I am in two-dimensional space, I don't have a roll and I don't have a pitch. Pitch and roll, it's only in three-dimensional space. So I'm pretty much good right now. I have created a goal message, and then I created the timestamp, the frame, the X and Y coordinate. Of course, the Z coordinate will be equal to 0. I didn't specify this here, but if you want to make a Z coordinate, it will be equal to 0.0 because it's not, we're only in two-dimensional space. Okay, that's good. And the final thing, we need to send the navigation goal. Now the navigation goal is created, but is not transmitted, is not published. Okay, we say publishing in topic, but we will send it through the action. Okay, we will use the action to send the navigation goal. Okay, let me create this. Okay, sending the navigation goal. And then, okay, I need to change this nav action because here I defined it as the nav action. Wait for server. So we need to connect first to the action client. It's not like topic we need to send. First of all, we need to connect. Once it's connected, you are going to send the navigation goal using an asynchronous function. So it's not blocking. And I will send the goal message. And finally, add one callback, goal done callback. Of course, I can make goal done callback or intermediate callback. This is the simplest way. I should remove the return right now. Now, if I have a goal coordinate, I am able to send it. Okay, that's fine. So what we can do, we can just make a function call. Or maybe I can make it in the init function. So just it will be executed right away. It's not the best way, but and now I need to specify X, Y, and okay, let me make 2.5, 1.6, and 0.0. Okay, everything seems smooth right now.
Shouldn't we change the parameter position Y to position Z?
Mm-hmm.
The last goal message position dot Y equal to 0 should be position Z equal to 0, right?
What? Ah, yeah,
Goal
yeah.
message.
Yeah, this one is.
No.
Yeah,
This one has to be fixed.
W and upward. And the position.
This one?
Yes.
Yeah, Z, yes. Must be equal to 0. Yes. Now I think we are fine. Okay, so again, I'm going to start Turtlebot 3 robot.
You don't need to compile first.
Yes, I need. And here, this is the navigation stack using the map. This is RViz. It did not show the map. There is an error.
Because you run the total map before you combine.
No. This is the navigation stack. Yeah, sometimes it's just stuck. I need to restart. Let me restart everything. Okay, so sometimes you just need to restart. Maybe it gets stuck somewhere. I need to make 2D pose estimate. Okay, now we have everything. I will just remove this and this. No, not the map, but the global planner and the controller. And let's see what is the point. What's the point we selected? 2.5 and 2.5, just to make sure. This is 2.5 and 1.6. Here, somewhere here. Yeah, somewhere here. Okay, now let's try to run our code. Control C. ROS2 run. ROS2 nav Python, and what is the name? TB3 nav. Yes. Okay, the tuple has no okay, quaternion. Yeah, I see. There is a problem, so it's not .x, it's a 0 or 1. Just a moment. Yeah, I, okay. So this one is 0. It's like a list. This one is 1 and 2 and here 3 to make the correct assignment. So I will compile again. Okay. We will compile again, and I will execute the code with putting RViz here in the front. Bismillah. You see? Okay, let me show the global path planner, and we can see the path. Okay. So of course now we don't have any control. You start, it goes. but of course we can specify through the keyboard. Okay, let's improve this a little bit. Okay, voila. Now you can develop a program in the robot. It receives a location, it can execute the navigation, and this is what we want: autonomous navigation of the robot in a free environment. Okay, now if you want to add semantic location, which is always better, of course here we don't have too much semantic because this environment is classic. But look, I will give you an assignment to do it this week. You will build a map like this for a house environment, and then when you build it, we can specify particular locations. For example, this is the kitchen, this is the living room, this is the bedroom. Okay, and in this case we can specify what is the location of the kitchen, what is the location of the living room, what is the location of the bedroom, and we can have semantic location. But now let's try to implement a very simple version of that. So in the way I implemented here, I did a JSON. We can define a JSON format, a list of JSON here, list of locations, and let me specify point 1 because we don't have kitchen here or something else. I will close that. Point 1 will be this location. 2.5, 1.6, and 0.0. And I will specify a second point. Point 2. Okay. Now instead of making send goal this coordinate, what we can do, we can make, instead of this, location str. Okay, so location str here, we're going to make, for example, point 1. Okay, send location point 1, and then send location point 2. I will make 2 executive points. And we need to modify here. So what will be the modification? You got a point, name, and you want to extract the value. Yeah, we will read from the JSON as I did here. Okay, so I will make location.x. But the location here, yeah, it's not .x. No, it's location JSON. Okay. Yeah, we need to do something first. Yeah, we need to take the correct location. So it's basically here. So let me make a function, a different function, def get coordinate from location. And here I will specify a location as str. Okay. So from this str, we're going to run this function. for every location in locations JSON. We will check. Okay. Okay, target location. Target location. Okay, if it contains the target location, okay, it will return location X location X, and then location. Are you following? And location what? Theta. So I will return 3 values that corresponds to this location. Okay, so now inside, since I made a function here, I will just call, I will call this one target location, and here I will put self, and here I will put as well self. Is there any error? And here I will get X goal. So what we should do? X goal, Y goal, and yo goal equal. صح ولا لا؟ Okay. Let me make here send goal 3.3 to make a point that does not exist. I'm ready to compile. So let's start this one, and let's start this one. Okay. What I should do? Execute the code. String indices must be integer. What does it mean? What did we miss? Ah.
It's goal. By goal, your first it will be the in the case of four values, the name and X, Y,
Yeah, but what is locations here? Let me. JSON.log. Yeah. Just a moment. Yeah, I missed something. Because this is a string, and I need to load it as a JSON. Location JSON is a string.
And you want to put it in,
Yeah, I need to load it as a JSON, so then I can have access. Okay, this was missing, you know. Okay, now I can compile again. In principle, it should work. Because the list was created as a string, and then we use JSON.load in order to convert the string into a JSON. This is like the typical way. Okay, something else now. What's going on? But I don't know where the error was.
in the board.
No, I think it's making an error here, no? It's basically the same JSON. Maybe there is this, let me remove this, compile again. There is a problem in loading the JSON. I think the JSON was not correct. The JSON probably was not correct. String indices must be integer still. In locations. Yeah. Another error. If location name, yeah, because now location, from locations, yeah. I didn't change this one. I didn't change this one because this one was loaded to JSON, and I need to check here within JSON, not within the. Yeah, that was. I will change it in this way. The naming was a little bit confusing, so now it will make sense. صح ولا لا؟ Okay, let's compile. Okay, now RViz. Is not defined. How it is not defined? It was defined here. Okay, any other error? I hope now all will be fixed. Still, navigation goal, then callback. But it was executing this one. We did not change anything to this one.
We get the comma back after the position of the
Yeah, maybe because it is sending 3 locations. Okay, let's start by one. Is there anything missing now? Also, let's print these 3 values. And target location all together. Sorry?
Application has four
Yes. Okay, it started to move. Mhm. Yes. We need to send the other navigation and after it finishes. Now it finished. Okay, so at least we can manage with the. But if we want to make multiple nodes, we need to wait until the finish of the first navigation to start the second navigation. Okay, now I have introduced this code. I will share this with you. I would like you to do the following for